Okay, hi everybody. Welcome to session 3 of Harmonic Experience for the summer 2021. Hope you're keeping up with us. We're saying that you should be up to about chapter 5 in the book and that's going to serve you very well as we move forward talking about ratios and the lattice and all that. Okay, we're going to start with a little experience first of all. So we're going to do some of the things that the book was telling us to do, and if you didn't do it, it's going to be kind of fun. So take 2 pencils with good solid erasers that are pretty much equal. And now this is what we're doing. We're going to find notes in their specific ratio by playing those notes. Okay, so let's just start with one. Let's call this note C in our right hand. Okay, so let's all tap C. Ready? Here we go. All of our notes are tapping C. Very good. Now, let's pretend that you are playing 2 notes, which you're going to play. It's not pretending. You're actually playing 2 notes. Now, you're going to take this as a C and this is a C, and they're going to be exactly the same. So both of them are going to be on a 1-to-1 ratio, we'll call it, right? So you've got a your right hand is C, your left hand is C. But because it can be any note, the more accurate way to call it is a 1-to-1 ratio. For every one of these taps, you got one of these taps, right? It's sometimes a little elusive to be able to hit them exactly at the right time. So close your eyes and let's have each person try it once. Okay, so Art, go. Good. I heard maybe one of those that was perfect and the other ones were a little either chgung or chgung, right? Because it's really kind of hard to really hit those at the same time. Okay, Tom, go for it. Good. So the first one was really dunk, and then the other ones started to settle in, and some were right on, and some were less. Aaron, you want to try that?
Yeah, I can try that. I'm gonna on a book here.
Okay. Very good. So various levels of togetherness and non-togetherness, right? As you listen to all of these, and it's the same for all of us. So to be that precise, to be that in tune, what somebody once said that, or an old Indian proverb or something, if 2 strings were actually in tune, they would break. Just something to think about. Okay, so let's now change the ratio. Let's go to the next most complex ratio. For every 1 C, I'm going to double this one. So what does that make this note? It makes it a C, the next octave up, right? So if I tap 1 here and I tap them together and then I tap this again. 2, 1, 2, 1, 2, 1, 2. Yeah, that's a 2-to-1 ratio. That's a kid singing with his dad. That's the high voice and the low voice together an octave apart. So for every 1 vibration here, you got 2 vibrations here. Now, Art made a very interesting observation, and we're going to talk about that in a minute. Let's try 2-to-1. Ready? 2, 3, and. 2-to-1 is the perfect way to describe. Here's 1, or 1-to-1. Here's 2-to-1. So we're playing this as the 1 and this as the 2-to-1. And there you have it. If we wanted to get the next octave up, we would have to turn this one into how many beats? We'd have to do it in 4, right? So now to get the next octave up, it has to be. And don't speed up your 16th notes, of course, but now we get up to this one. So this one's ratio is a 4-to-1. Okay, so we know exactly what note we're talking about. Now, here's the interesting observation Art made. He said he heard this somewhere or he read it in the book. He maybe both. That is, that if you now can speed this up fast enough, if you can speed these vibrations up into the, say, 100s or so per second, you'll start to hear pitch. What you are doing is creating vibrations by hitting on a surface. You're creating vibrations that are too slow for us to recognize as pitch. But at some point, you start doing this really fast. I can't get but maybe 1, 2, 3, 4, 5, 6. I can maybe get 8 in a second if I'm lucky, or maybe a couple of more. But I don't hear that as pitch. I hear that as a thud, right? If it goes 100 times per, and my hand can go really fast, I can get 100 times per second, I'm going to start to hear pitch. And that's absolutely true. So if you record it and you have a recording device that allows you to speed things up like that, you can do this test. And if you do this, if you do, you'll hear an octave. You'll hear the 2 pitches, right? And you can get any one of these ratios, but we can only do so many combinations of ratios with our 2 hands before it becomes too complicated and too difficult for us to do. But now we've got these notes. What is, and these are partials, right? So let's get this one back in here. What is the ratio of that G? We talked about it last week. That's our 3-to-1 ratio. If we divide a string into 3 equal parts, we get the 12th or the G, right? So here it goes. That's the ratio of the perfect 12th, right? So if we were able to speed that up, this is C, this is G, an octave and a fifth higher when we do 3-to-1. And if we could speed that up, we would actually hear this sound start to appear. Okay. Yeah, if you could, that would be great. Let's see, do I bring that in now or do I talk about that later? Okay, I'll talk about that later. Okay, so now we've got these several ratios going on that we can actually talk about what our eardrum is doing and what the sound waves are doing in the air. These are the frequency ratios that we're talking about that help us to identify the actual just intonation tunings. Now, we want to get a little bit more complex than that. We're talking about octave reduction from last time. This C and this G are too far apart to work with very easily. So, and they'll keep getting farther apart. We would rather see them like this in a line, do, re, mi, fa, sol, la, ti, do. We'd rather see them like this. We want to see the fifth this far away. So in order to get that, we've got to change the ratio. We've got to get rid of the extra octave, which was here, so that we can talk about the perfect fifth only. And how do we do that? G is represented by the 3. C is represented by the 1. So if I want to get these notes closer, I got to get rid of this octave. This is what we call octave reduction. So how am I going to do that? I'm going to take the 1, which is C, and I'm going to change it to a 2. I'm going to double it. And that gets rid of this one. Now my notes are a perfect fifth apart. So the ratio of a perfect fifth is 3-to-2. The question is, can you beat 3 against 2? So if you can't, and you don't necessarily need to know how to do this, your eardrum already knows how to do this. So everyone would say ta ta ka ta 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 ka ta 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 ka ta 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 ka ta. That's the feeling of the hemiola, 3 against 2. Okay, so here we go. Slow. Ta 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 ka ta 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 ka Now, if you could speed that up, you're going to hear this. You're going to hear a beautiful, perfect fifth in perfect relationship, right? The rhythm of 3 to 2 looks like this. Feel it like this. And this is both hands. So let's see, right and left, ta, right, left, right. And you'll have 3 against 2. And you'll feel like put a little accent here, ta, 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 ta.
But because it's quarter note triplets, it's just slightly like different than that, let's say.
Say that again.
Because you're superimposing 3s, which is, you could imagine it as triplets.
You could imagine it as a triplet.
So you're smushing in 8 note triplets with 2 quarter notes.
With 2 quarter notes.
Right.
If you want to change the values, you can, but you'll notice how beautifully divided it is here.
Right. You could see it clearly written that way.
Right. You got half and half, right? So
Right.
this one is going here and then accenting a little bit. Maybe I'll put the accent down here. So 1, 2, 1, 2, 1, 2, 3, da, da. That makes sense. Let me try that again. There we go. So we got. Now I'm going to count 2. So 1, 2, 1, 2. That's my left hand. 1, 2, 1, 2, 1, 2. Here's my right hand. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. The genius thing is that our eardrums know how to do this automatically. When those waves get set up by the pencils, they're traveling through the air, they're hitting my eardrum, and they're going at a perfect 3 to 2 ratio. My eardrums are moving that way. I think that's amazing, right? So it doesn't matter really how you notate it. That's just a help. Don't think of it it's not in a time signature. And I think you're thinking of it in a time signature.
Well, the thing is, if you divide something by thirds, it's 3.3333, right? But this way, you're dividing it in duple things. So there's a slight discrepancy if you divide things by 3 versus 2.
Well, but what if you put a 6/8 time signature in front of that?
There, that's more accurate right there.
But it wouldn't change the timing.
That's true, but the mathematics, if you think about it, mathematical wise. So you're dividing that first half by thirds, but with that, you're dividing it more like evenly.
Well, but a quarter note is twice as long as an eighth note, so it seems like you're still.
Right, that's true, yeah, that's true.
I hear what you're saying. I think you're perceiving it in a little different way than, let me see here. If there's a good diagram of it. If you go to,
It's like quarter note triplets against 2 quarter notes. That's how I'm envisioning it.
okay.
Yeah,
Go to page 23 in the book. If you look at page 23, you're going to see exactly what we're talking about.
23.
Yeah, page 23.
Right. Yes, that's why the figure 4.2. That's how I'm kind of like
Yeah.
envisioning it.
Okay, which is
Or
fine. You
4.2.
still got the 3 full divisions, which equal, whether they're 3.33, there's still 3 full divisions of a 1.
Right.
1, 2, 3, 1, 2, 3. So that would be, yeah, 3 to 1 ratio. And then we figure 4.3 then turns it into a
4.3,
3 against 2.
Mhm.
So you're still dividing it exactly in half. And I think the math works out. And so you can see different ways of looking at it. Look at where it says 3, 4 on figure 4.4. And you see for 1, you're striking both together, right?
Mhm.
And they both strike. And then you go 3, 4, 5, 1, and 3, 4, 5. get that rhythm.
Right.
Okay. Yeah, very good. Okay, so
I'm wondering in this representation of each pencil is a different pitch that one is resonating at one frequency, the other being twice as fast, or being the 3-to-2 ratio or something. I'm wondering if would that mean the point at which both pencils touch the surface at the same time, would that be a point when looking at these two waves simultaneously where they both cross the center point together, like where that's where they happen to meet up together?
that would make sense. And there's always going to be a point where they meet. There's always going to be a place where the cycle starts over again.
Right.
Yeah. Yeah, and I think it mentions something about that in the text. Good, okay. Now, we've tapped a 2-to-1, which is an octave. We've done a 4-to-1, which is the next octave. We've done now 3-to-1, and then we turned it into 3-to-2 so we could get them within an octave. The next one that we need to feel is the ratio of the major third. Now, Aaron told us earlier that he was practicing every day, listening to his overtones, and he was starting to hear them. Hasn't quite heard the fifth partial yet, but he's going for it every day. Now, you can see that the ratio just got more complicated as soon as we started talking 3s against 2s, right? As you go higher in the overtone series, they get more and more complicated. So our ears like the simplicity of the low primes and the low ratios. So when we're hearing things, we relate things closer to the lower primes, if that makes sense. It'll make more sense as we go. So let's see. Here's our C. Here's 2. Here's 3. Here's 4. Here's 5. A 5-to-1 ratio is too far apart. I got to get rid of 1, 2 octaves to get it closer, right? So what am I going to do to get it? 5 represents the E, 1 represents the fundamental C. What do I have to do to get this ratio between 2 and 1?
Double
What do I
it.
have to do to get rid of the octaves?
Double it twice.
I have to double this twice. 1 becomes 2. 2 becomes 4. And now, where was I? Oh, not the 3. 2 becomes 4. And now I'm from C to E, right? So 5-to-4 is the actual ratio of the major third from C to E. I now have these notes in my scale, by the way. I've got, look at that, with the ratios we've looked at so far. The major triad exists in those low primes of the overtone series. So now we're at C and we're at E, or if I want to put my C here, I can. Now, can you do 5-to-4? It's much trickier. But it's not that tricky, and you don't have to know how to do this, but here it is. That's not that difficult if you hear it as da 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 da. If you kind of put the rhythm together into one thing, it starts to make sense. So I'll show it to you in the book if you want to see how that looks. Go to page 31. Actually, let's go to page 30 first. Page 30, octave reduction of the fifth partial. So look at the first ratio, 5-to-4, and look how far apart those notes are from C all the way up 2 octaves and a third up to E, right? The rhythm is 5 against 1. Oh, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Or if we can do it 5 against 2. I'm not going to do 5 against 2. I don't feel like it. And I've never internalized that. 5 against 4, I have internalized, but you can see how we keep getting the notes closer together so that they're easier to work with. Okay, so let's look at page 31, and you can see the rhythm. If you just tapped it with one pencil, ta 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 ta, or if you just clapped it, right? Ta 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 ta. And you can see how symmetrical it is. Look where the 16th notes fall. Look where the dotted eighths fall. Look where the eighth notes fall. And that makes it kind of easy to see. So, ta, ti, 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 ta, ti. Here's my C. I'm sorry, I've got them backwards now. Okay, so here's my E and here's my C doing 4 times. 4 against 1. Sorry, I learned it that way. So it's a little harder to switch hands. There it is. And now you can tell people, look, I can do 5 against 4, and you realize that it's just a little rhythm you're hearing in your head, just like the hemiola was ta 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 ta, right? You can play 5/4 very easily. And you look like you're, really advanced, but you're not doing anything that's really advanced. You're just playing that little rhythm in your head. So there you go. That's 5/4. Is it important that you know how to tap this? No, it's not. Is it kind of fun to show that you know how to do it? Yeah, your eardrum already knows how to do it. So don't worry if you can't get it with your hands. But there's the ratio of, now, 5/4 ratio is much more complex than 5/1. And as we keep getting higher in our overtone series, the ratios are going to get more and more complex to where it's impossible to even try and do this. Can you tap 9 against 8? Can you tap 10 against 9? But those are the 2 ratios of the Ds that we sing every day, that we sing whenever we're making music. We sing those 2 Ds within the pieces of music that we sing, the 2 kinds of second scale degrees, and that's not even the equal tempered D. So there's at least 3 Ds that you can sing pretty easily, and we'll be demonstrating that more as we go. All right, so that takes you all the way up to the end of chapter 5. If you can get that far, I think that's going to be great. Now, here's the whole premise. The whole premise of this study is that our ear enjoys the low prime ratios. Our ear latches onto those and tunes to those. And sometimes the ear has to, or the voice has to change to accommodate the difference or the different note that you're singing. And so when you're singing a D, we did this a little earlier. Let's do it again. Okay, so everybody sing. I'm going to play a C, then a G, go up another perfect fifth in a Pythagorean move of perfect fifths. There's my D, right? Okay, so everyone sing D. I'm not going to play it. I just want you to sing it. Okay, so the D that you're actually singing is not the equal tempered D, which is different. It's the just intonation or the justly intoned D that is related to the G by fifths. Okay, it's Pythagorean. But there's another D. I'm going to tell you, there's another D that we sing all the time, and it's related not through the dominant G, but through the subdominant F. And if we sing a D against that, and I put F in the bass, and so if you say, well, they sound exactly the same, I'm going to invite you to keep listening and keep listening deeper and deeper, and go to the piano and try this a little bit. Play a C and a G. Sing the perfect fifth time, and then change to an F. And then you decide, do they sound the same? Do they sound different? I'm going to do this a few times back and forth. I'm going to go from CG to CF. And you're going to feel, because remember, D or D minor is a substitution for F. 2 is a substitution for 4. So it's related to the F. You can even call it a D minor 7. Related through that F, right? But that D related to the F is different than the D related to the 5/7 chord or the 5 chord. So here's our two Ds, one with a CG, one with a CF. Here we go. Let's just keep singing it. Take a deep breath, keep singing it. Feel if it changes when the chord changes underneath it. And then breathe and do it again. Ready, and now, apparently we're singing the same D, but maybe we're not. Art, what are you experiencing?
I feel on the F chord, it needed to go down ever so slightly,
Okay,
just ever so slightly.
the D went down ever so slightly when the F hit.
Right.
Okay.
Is that because also the interval between the F and the D is like a major 6? Or I shouldn't think about it in that way.
You're going to see how they're connected when we get the lattice on the board. Okay. Tom, what did you experience?
I also felt like it went down a little bit, um, and it got a lot warmer.
It got warmer.
I like that.
Okay, yeah. Yeah, it does have a warmer feel to it. I feel that too. Everyone senses these things and describes them differently depending on their own experience, and that's right. But I do feel it as warming up. Yeah, very
When
good.
you did it earlier with the piano,
Mhm.
and then we sang that, but you were playing the D.
Yeah.
I felt that it was too sharp. It's too like in your face. Almost.
Okay.
It's like it's almost offending. Almost.
Yeah, it's almost offensive, says Art.
Yeah, almost.
Yeah, almost. No, I totally understand that because when you're singing the tuning that kind of goes against the low prime ratios, um, it's a different feel.
Yeah.
Yeah, and it can be a little offensive. How funny. Okay, Aaron, what did you experience? Did you get much of that over there?
Yeah, it feels like it is weird to say because it's not theoretically moving, but it feels almost like it's resolving. Like
Uh-huh.
it's a little, the first is very tense and then it just kind of relaxes a bit. It gets, like Tom says, gets much warmer for the second change. Yeah.
That's good. And you all sensed this when we stood around the piano on the first session and we played two different A's. And we said there's two different kinds of A's that you can sing at least within the just world, right, of tuning. And so we felt this, and you all had descriptions. And I remember, Aaron, you said it felt like it locked in when you sang with the second chord or one or the other, right? But you felt that, and you're saying it's resolve. You're using the same kind of language here, so I think you're feeling that same kind of sense. There's two kinds of Ds that you can sing in different contexts besides the equal tempered D. There's two kinds of A's or sixth scale degrees. Of course, I'm always referencing in C, but this goes for any key that you're in, right? Okay, so what about the 5-to-4 ratio? Let's hear that one again. I'm playing C's, G's, and C's in the piano, a perfect fifth, and you sing the E above that. Ready? Here we go. I'm gonna offend some of you. I'm gonna stop playing and I'm gonna play the E as it's tuned on the piano after we've sung the justly intoned E. Okay, so feel what it feels like. What does E feel like when you sing against the low primes? That's different, isn't it? Do you sense the difference or do you not sense the difference? That's something to explore because the one on the piano is sharp to the one we were singing in frequency. It's got a different feel to it, right? There were times where I was singing that E and I could feel myself, I could hear the interference in my voice with the notes on the piano, and then it would settle in a little bit lower and it would get to that perfectly tuned pure third or overtonal third. That's too high. Is warm. It feels beautifully in tune, but it's not in tune with the piano E in equal temperament. That one is 14 cents sharp. So if a major third is 400 cents, which it is, each half step is 100 cents, as we said in our general terminology. Each half step is 100 cents. The major third then is 4 half steps, that's 400 cents. But the overtonal E that we were singing, the justly intoned one, is 386 cents. And we can hear that 14-cent difference. We can sense it. I got to really try to make that higher if I want to. Hence, many conductors saying, please make the third higher, please make the third higher, because they're hearing it in equal temperament, right? And that's what they want. And sometimes this is the prettier one. Doesn't feel as nice, doesn't feel as warm to me. That's a different feel. Two kinds of E's. The discrepancy between one E and the other E, or one D and the other D, these are called commas. It's that little discrepancy of pitch that is sensible in a lot of cases, and we can hear them and we can name them and we can say, okay, those are two different things.
So are you saying if we play, for example, that low C,
Mhm.
and if you could hear the fifth partial, you could just match that fifth partial,
Correct.
right?
Yes.
But that fifth partial will not match the fundamental of the actual E when you play it on the piano.
Yes, I think you can say it that way. So sometimes I'll have my choir and I'll go, okay, sing C's, G's, C's, and then I'll another G, and then I'll say, or I'll do C, G, C, like the overtone series, and I'll say, okay, now listen for that E. I remember my college teacher doing this, and we would listen for the E singing up high somewhere in the overtones, and I would say, okay, match that note if you can hear it. And when they would match that note, they would be matching the tuning of the overtonal E instead of going to them, here, sing this. Because I'm already starting them out of tune.
Right.
If we're going to sing a cappella. If we're going to sing with the piano, then it's different.
Would it be advantageous if you're singing a cappella group, and then you use this piano to do the sample C, right?
Mm-hmm.
But at the venue, you use another tuning instrument that might not exactly match the tuning that you have this in this specific piano.
Mm-hmm.
So would it be saying just use the same exact tuning instrument that you have, because and then go from there so that they would be more audio, they would remember exactly. It's almost training for perfect pitch, right?
Yeah.
So it's like,
Well, you go to Cal State Fullerton and you watch them perform, they all for every song, take out their tuning fork.
Okay,
And they all hit it and they listen to their note, they find their note and they start singing.
okay.
Um, it's instead of the conductor doing that and then going, "Ooh," singing it to everybody. Another way is to give each section leader one. The section leader hits it, listens to it, and while the audience is clapping, they're giving pitch to everyone else. And now the clapping stops and we start the next song and everybody knows exactly where they're at. That's a neat way to do it. I think everyone pulling one out is maybe overkill, in at least as I see it, especially when a person drops theirs on the stage. And cling, cling, cling all over the place. But you could accomplish that with 4 very easily, 1 in each section. And then you're always tuning off the same thing.
The same thing.
Yeah.
So it's consistent.
So it's consistent. Yeah, sure. That's totally a valid way of going about things.
Well, it seems to me that when you do this, you're very much tuning in a relative way. And
Right.
you want to train people to tune in a relative way.
Uh-huh.
So if you make it absolute, then that it's kind of a different concept you're posing.
Well,
Yeah.
The only absolute I'm saying is the like a starting pitch. Like for example, there has to be a standard 440 hertz, right?
Mm-hmm.
You know what I mean?
Yeah.
So that the only first bass note is the whatever, and then you relative pitch from there, right?
Well, very often, as in practical matters, when we're singing, say, a Renaissance madrigal, I will often change the key up half step, down a half step after they know the music and they've learned it. And most of them can do that with ease. They feel that it's different. Sometimes I won't even tell them, and I'll give them starting pitch a half step higher. And let's sing it and see how it feels. Sometimes the half step down is perfect for the tenors and everybody else can hang with it. The basses don't go too low, depending on the song. And so we sing it in that key all the time because we're not going to sing it with the piano. And it's perfectly valid that the composers of the day probably expected that anyway. If you sing it later in the day as opposed to earlier in the morning, you might want to change the key. You know, the Gregorian chant guys were doing this all the time.
Right.
You know, it's no specific pitch.
Right.
Well, then there are people, even people who don't actually have perfect pitch, who just can't sing it in a different key.
Yes, that creates problems with some people.
Or you'll feel different.
And choirs that sing out of tune, and often it's usually going flat, right? So as the choirs are singing out of tune, they end up singing it in another key anyway, by the time they're done, right? So if you can keep them in the same key or start them in a different key, you'll find that sometimes it's because of the vocal ranges for this group of kids or this group of singers. You're going to find that moving it up a half step gets it off of their break just enough that it makes everything sing better. And sometimes bringing it down a half step or a whole step even might make a difference and might make them sound better on the piece.
But not too extreme enough that it really kind of messes up their sense of, you know, the way they remember it, even subconsciously.
Yeah.
Right?
Which is why it's good to sing it in several keys. Why not get their ear used to hearing it in different keys instead of just one?
Right.
Because the composers weren't thinking like that. It wasn't like Bach or Beethoven who were writing in a specific key and wanted it to sound this way. It was, you know, Renaissance composers were writing the notes down and okay, so if we got to change the key, let's change the key. Who cares? Who cares as long as it sounds good, right? And so training singers to be able to move into the different keys and sing in different keys. It's like warm-ups. Why do we always warm up in major? Why don't we warm up in minor? Why don't we warm up in Phrygian? Why not, right? Let's train our voices. When I was learning how to sing modes, it made a big difference for me because I could sing in major and minor easy, but to try and sharp a 4 or flat a 2 and stuff to get these different modes, it took a lot of mental effort. Still does, but not as much as it used to, but it still does. So why not train them to sing in those different scale patterns? Why does it all have to be major and minors or whole steps and half steps? Why can't it be augmented seconds? You know? Yeah, let's warm up in that. Why not? Especially if the music's going to have it. If the music is going to have an augmented second in it, let's warm up on some of those and get our voices used to something other than whole steps and half steps. Yeah. Okay, we're getting on a little tangent. All right, let's do this. You might want to take a sheet of paper just to doodle. This is not something you have to keep forever. So there's staff paper right there. Everybody grab a sheet and let's build the long-awaited promised lattice. All right, here we go. Let's take the key of C because that's what we're doing with everything. What is, okay, so let's get the notes that are closest to this C in the overtone series that we've been talking about for 3 weeks now. What is a perfect fifth above C? It's a G, so let's put it here. Okay, let's see, should we build lattice first? Let's just build the whole lattice. Let's find all the notes and see how they all relate by perfect fifths and major thirds. Everything relates to the ear, easiest by perfect fifths and major thirds. And we're going to find the notes that are closest to this C and being generated by this harmony. This is a 3-to-1 or a 3-to-3, let's just call it a 3-to-1 for now, from C to G, which is a 12th. We've already said that if we double the C, we get the perfect fifth. Okay, so there we go. E is the fifth partial. So let's put it up here. Major thirds then are going to go up north-south, and perfect fifths are going to go to the east. Okay. What is a perfect fifth above G? D. D. So D will be here. And what is a major third above G?
B.
B. Sure that can all be seen on the board. Okay. So look at that. We've got another perfect fifth relationship across the top here. We've got CG right here with CGD. So we're getting a Pythagorean spine of fifths, right? Okay, let's keep going. What's a perfect fifth above A? Above D. Well, there it is. It's A. Okay, there we go. What's a major third above D?
F sharp.
F sharp, which is a perfect fifth above B. So we've got two parallel spines of Pythagorean fifths.
It's in the circle of fifths acceptance.
It certainly is the circle of fifths, right? The center is the circle of fifths. So now let's look at it. We've got C, D, E, F sharp, G, A, B, C. We've got all the notes of the scale except for one. Which one are we missing? F. We're missing F. Where does F fall on this diagram?
To the left of C.
To the left of C, right? I like to tell the students when we're looking at it, if C is the creator of the C universe, then F would be the Virgin Mary. Because it's almost like F is generating the C, right? But here's the thing, this direction is the overtonal direction. This is the overtone series collecting up here and compounds of the earliest ratios. F sharp appears in the overtone series, way up high, it does, but F never appears in the overtone series. So we have to hear this differently. We have to hear it as a perfect fifth down, and the ratios which are different, we've learned from equal tempered piano to just intonation, the ratios which are different are also going to be different, but now we have to hear them as upside down or reciprocal. So this is a reciprocal fifth, and it looks like the circle of fifths still, but take a look at it. Notice that when we go to the dominant or the subdominant, why is this called the dominant and this called the subdominant? This is the subdominant because it's the dominant underneath the tonic, right? Dominant is the fifth above. Subdominant is the fifth below. A lot of people learn this wrong. Some books teach it wrong. Some books say that F is the subdominant because it's underneath the dominant,
G, right.
and that's not correct. That's not correct as far as the ratios go. That's not the correct as the way we hear it. All right, what is a major third above F?
A.
A. Well, this is interesting. We now have two A's on the board. Strange. Those are the two different A's that we sang a little while ago. Check it out. This A is in relation to, oh no, we did D's. We did D's. Okay, but we sang these a couple of weeks ago.
Right.
But these are, this A is related by fifths to the dominant side. This A is related by a fifth down and a third up. That's a different A. That's a different A. They sound different, and you're gonna see they have different ratios. Okay, let's go a little further. We won't go to the C sharp because C sharp in the key of C doesn't quite work, and it's getting farther and farther away. Our ear won't hear it probably as a C sharp unless we're modulating. If we're modulating to another key center, then we'll hear it as a C sharp, but we're more likely to hear that as a D flat, and I'll show you why in a minute. Okay, what is the next on this going in the reciprocal direction?
Flat.
It's a B flat. Okay, and what is the major third above B flat? D. All right, there it is. This D is 2/5 up to the Pythagorean side, or to the dominant side, the overtonal side. This D is down 2/5 and up a third. It's more close to the subdominant. It's related to the F. Here's a D, F, A. Here's a D minor triad right there, right? So your ear can hear this one because it's not too far away from C, and your ear can hear this one because it's not too far from C. But they are different ratios. We'll get to the ratios in a minute. So which one do we sing? Do we sing the equal tempered D, or do we sing the dominant side D, or do we sing this one? And what happens if we're on that note and the context changes, our tuning has to change along with the context. Otherwise, our choir can go horribly out of tune if they stay stuck on one D. And good intuitive singers know how to do this. They know how to do it, just they hear it, doesn't sound in tune, so they tune up by major thirds and perfect fifths. All right, we got to get more flat notes on here. Going up is the Ga dimension, or Ga-blooded notes, right? So this is the Ga spine, this is the Pythagorean spine, and this is going up one. So it's a spine of major thirds above these notes.
Ah,
What if-
Pa for Pythagorean,
Say,
huh? Pa for Pythagorean.
Pa for Pythagorean, you can think of it that way, sure. Now, what if we go down a major third? What's a major third below C?
Is
A flat, right? Okay. We're going to get all 12 chromatic notes here, circling around C. All right, let's see. What is a major third below G?
E.
There's our E flat, and oh, lo and behold, we've got another spine of fifths starting. Okay, what is a major third below F?
C sharp or D flat.
Has to be a D flat, not a C sharp. C sharp would be a third. It would be a fourth.
Right, right.
Okay, so we got this spine of fifths down below. We have, I believe, all notes of the chromatic scale and a couple doubled. C, D flat, D, E, F, F sharp, G, A flat, A, B flat, B. There's all the notes of the chromatic scale, and this is how close they are. These are the closest ones to C. We can find more. We've already found two Ds, and we've already found two As. Now, here comes the fun part. Let's see, is this marker working well? I hope it does. All right, let's. All right, the fun part is figuring out the ratios of each one. So Just let me draw this little diagram for you over here. I know it's looking like it's becoming math, and this is the math part. Okay, if you go 1/5 over, you multiply by 3. Because that's the ratio of the perfect fifth, or the 12th, right? Go this way a little bit. All right, there I am. All right, so times 3. If you go up, you're going to multiply by 5. If you go reciprocally, what's the reciprocal of 3 to 1?
1 to 3.
1 to 3. So you're going to multiply by 1/3 if you go this way. And what's the reciprocal of 5? 1/5. You're going to multiply by 1/5. This is when we talk about harmony is multiplicative. This is part of what we're talking about. Okay. Now, let's figure out some ratios. Knowing that this is how we do it, and knowing that we always want our ratio to be between these two so that we keep them in an octave, we're going to find out what is the exact frequency ratio of each of these notes. This you might want to watch several times. Okay. Using octave reduction, we already called this G a 3 to 2. Can you see that okay? Is that not dark enough? Let me try green. Is that better? Okay. What's the ratio of E? You go up, so you multiply by 5. It's a 5 to 1. But then we've got to get it between 1 to 1 and 2 to 1. So how do we do that? We double this, double it an octave, double it twice, becomes 5 to 2, then it becomes 5 to 4. The ratio of E, the overtonal E, is a perfect 5 to 4 ratio, okay? All right, let's get the ratio of this D. Using this little chart, from C to G is times 3. From G to D is 3 times 3.
9.
That's 9. C is 1. That's too big a number, 9 over 1. So what do? Change the 1, double it to 2.
Is it double it twice?
Double it again to 4. Double it again
Again.
to 8. Now my number is between 2 and 1. 9 to 8. If you divided 9 by 8, it would be 1 with a remainder,
Right.
right?
Or you could picture how many spaces it is, and that's how much doubling you have to do.
Correct.
Kind of.
For the octave, not necessarily.
Oh, okay.
Okay, so that's now a 9 to 8D. Okay, let's figure out the ratio of this one using this little chart. We go over 1 times 3. Go up 1, 3 times 5. 15 to 1. How do I octave reduce to get it close? Double the 1 becomes a 2. 2 becomes 4. 15 to 4, no. 4 becomes 8. If I doubled 8, it would get to 16, and now my number is smaller than 115 over 16, and that doesn't work. So I stop at 8. The ratio of the B, the major seventh in any key is a 15 to 8. 15 vibrations of B for 8 vibrations of C. Can you tap that with your pencils? Neither can I.
Now, how can you keep track on how many octaves away a certain pitch is? That, you know what I mean?
you keep raising the C until it gets as close as you can to that
Got
number
it.
without going over.
Got it.
Makes sense? That's a very good
Yes.
question.
Yes, yes. That makes sense.
All right, let's figure out the ratio for A. Times 3. Times 3 is 9. What's 9 times 3?
27.
27. The ratios are getting more complex. 27 to 1 becomes 27 to 2, 27 to 4, 27 to 8, 27 to 16. If I double it again, I go over,
Go over.
so it's no good. So 27 to 16. For every 27 pencil taps here, I do 16 here. Well, 16 here and 27 here, I'll hear the note A, the Pythagorean A. But as you're going to see in a minute, okay, so you're going to see that these ones have different ratios, which means they have a different frequency. And the further you get away from C, the less likely your eardrum is to vibrate at that ratio. It can do it. It can do 27/16. It sure can. But it's getting pretty on the outskirts. The harmony is getting very far away. And so we don't really perceive it that way. We perceive it much closer. The ear likes the simplicity of the lower ratios. Let's figure out that F sharp since we're here. Times 3. Times 3 is 9. What do we do when we go up?
Multiply by 5.
What is 9 times 5?
45.
45. And what's the number on the bottom?
8.
32.
32, thank you. Whoops. 32, why? Because it was 1, then it was 2, then it was 4, then it was 8, then it was 16, then it was 32. If I double it again, I go over.
Interesting.
So the ratio of an F sharp is 45 vibrations for 32 vibrations. That's ridiculously complicated. But your eardrum can do it.
Against C. That
Against C.
is right.
Okay. I'm tempted to leave this alone at this point, but because you can watch this over and over again if you're confused, and it's very easy to get confused, I'm going to keep going. So if you guys are game, I'm game. How do we figure out this one? And this is where it gets a little confusing. So if it's not confusing already, when we go this way, we divide because now we're listening upside down, kind of, right? We're hearing it differently. So we get to not multiply by 3, we multiply by 1/3, according to this little chart. We're hearing it as a reciprocal. So the C is now here, and the 3 is now here.
Right.
I still got to get this number higher than that number. So how do I do it? 1 becomes 2, double the C. 2 becomes 4. 4 to 3 is the number between 2 and 1. So I'm okay, right? So a 4 to 3 ratio is right. So let's see, 4 divided by 3, or a 4 to 3 ratio is equal to what? 1 goes in 1 with the remainder 1, right? So that's between 1 and 2.
So when you cross over from the overtonal side to the reciprocal side, you just flip where your C sits.
Correct.
Okay, gotcha.
Now, let's see how that makes the other A and the other D different. Well, no, I tell you what, let's go to the A flat first. So we'll get the concept of 5 in there. All right, so C down a major third is now a reciprocal third down. And so I'm going to put my C here, and I'm going to put my 5 here, times 1/5. 1/5. That number is not correct. So I've got to get this number bigger than that number. What do I do? 1 becomes 2 becomes 4, becomes 8, because the C, that number has to be bigger than that number. So now I'm at 8/5. The ratio of A flat is 8 vibrations to 5 vibrations. Not terribly complicated. I still don't want to tap it with my pencils, but this is my C and that's my A flat. Okay. So this way and this way is reciprocal. That's going to be turning the fraction over, and this way is overtonal. And we do it just times 5 going up and times 3 going that way. Okay, let's try and get now the A and the D, because I want to make the point of how they are different. So what do? I go this way, and it is times 1/3. What's 1/3 times 1/3?
1/9.
1/9. And now, oh, I went too far. I want to do the A first. Okay, so this is times 1/3 times 1/5. What's 1/3 times 1/5?
1/15.
Oh, no.
1/15. All right, I need to change this. What do?
Thought we were going up. I thought you multiplied going up.
Oh, you're absolutely right. I knew that didn't look right. Times 1/3 times 5, because I'm going up. There it is. The ratio of the A is pretty simple. I don't have to do any octave reduction because they're already close, right? So just like that's a 4/3, and I didn't, although I did change this one, this is times 1/3, which is the 3 on the bottom, times a 5th, 5 on top, 5 to 3. That one's not as hard to do. That one's probably doable. For every 5 vibrations, you got 3 vibrations. Okay. 5 to 3 is a lot simpler than 27 to 16, yet our ear can hear either one. But this is why they sound different. When they're related to a tonic, they sound different because they have a different ratio. And ratio is by far the more accurate way to describe a pitch, not a letter name, as we can now start to see. Because that A and that A are not the same pitch. That's a 27/16. That's a 5/3. All right, let's figure out one more. And this is this D. So 1/3 times 1/3 is 1/9. Go up times 5, 5/9. What do I have to do? This is my C, this is my D. I got to double my 5, and I get 10/9. That D is 10 vibrations for every 9. That D is not 8 vibrations for every 9. There's a difference in pitch, and we hear those 2 Ds as different, but they're still pretty close to the center of C. So your ear can perceive either one, depending on where you're at, depending on the context of the music. If I'm hearing lots of G's, B's, and D's in the music, I know I'm on the dominant side. That D is going to sound 9/8. It's going to sound higher in pitch. But if I come this way and I start hearing F, or maybe even a B flat chord, or an F to an A, I hear a FAC chord, that D is going to start to sound lower in pitch, which is 10 vibrations for every 9. Okay, makes sense? Should we finish this off? Let's finish this off. Okay, so down 1 is times 1/5. Over 1 to the right is times 3. So that's a 3 to 5. And how do we do this? We double our 3 and we get 6. The ratio of E flat is 6 to 5. Let's do the D flat. Let's go down 1, it is times 1/5. Go over 1 to the left, it's times 1/3, which gives us 1 for the C to 15. So what do? We double the 1. The 1 becomes 2, becomes 4, becomes 8, becomes 16. I don't have to go any higher because now I'm higher than this one. So the ratio of D flat is 16 to 15. Not as complex as F sharp, but still pretty complex. I don't want to tap 16 to 15.
How about this B flat over here?
Let's get this B flat. Times 1/3. Times 1/3 is 9. 1 to 9. Let's double our 1 becomes 2, becomes 4, becomes 8. Still too small, becomes 16. 16 to 9 B flat.
Interesting.
How about this B flat over here?
Uh-huh. Tom's thinking ahead already. Look at that. All right, Tom is saying there's a B flat here. What would be the ratio of that B flat if we're on the dominant side? Three times 3 is 9. 9 over 5. There it is. Nine to 5 may be easier to hear than 16 to 9, but still they're not terribly far away from C, so you can hear them. But you go one more step outward and it starts to get very complicated. And our ear doesn't tune that way. Our ear doesn't hear that way. It hears the simpler lower prime ratios. And they're compounds. That's what I was saying earlier today. So when I go from here to here, I hear D as a compound of C to G to D. I don't just hear it as C to D. I hear these compoundings of the ratios, and it becomes multiplicative. That's why harmony is multiplicative as opposed to melody, which goes by step up or down, 1 or 2 steps at a time, whatever it happens to be, 5 steps at a time. That's additive. Melody is additive. Harmony is multiplicative. Now, I'll show you one last thing, just so you go away. This is confusing. I remember writing this out over and over and over again, just to make sure that I understood the ratios and how to octave reduce to get them between 1 and 2. And so I just kept writing out the lattice over and over again, the thirds and the fifths. The more time you spend doing that, the more you'll internalize it. I'm going to give you a copy of that lattice. In fact, there's already one on Montoya's Great Listening, but I'll show that to you in a minute. What if I got rid of all these ratios? Should I do that yet? Let's see. I won't do that quite yet. Let's just look at some patterns. This is what I love about the lattice. There's my 1 chord, right? Look at this. Here's my 4 chord, FAC. Here's my 5 chord, GBD. There's my tonic, my dominant, and my subdominant, right? If I want to continue with that, let's look at the triangle as an upside down triangle. I've got my C minor. I've got my G minor. Wait a minute. Yeah, there it is. Okay, there's my small 5, and here's my small 4. So minor is reciprocal, major is overtonal. Okay, now let's continue on over here. What I got there? I got a 6 chord ACE. I've got a 3 chord, and it's all tightly packed and close together, right? And if I go back 1, I'll see my 2 chord. 2 and 4 are so close together, they're kind of related. So I start seeing shapes in this whole thing. If I want a dominant 7th chord, I can go GBD. Over here would be the F. There'd be another F on the overtonal reciprocal. But our ear is not going to hear that F so much because that F is going to get more complicated. It's going to hear this F, which is easier to hear because it's right next to C. Okay, so I've got all this stuff all over here. So what if I'm singing a D minor chord? Where is it? Yeah, we know that there's an F over here. But if we were singing this D minor chord based off of G, and then we came back over here to come back to F to C. This is where we're going and where we'll get a little further into it. Sometimes you're singing a whole chord and that chord now has to change its tuning in order because it starts to get associated with the subdominant side instead of the dominant side. And that gets a little more complicated. But you can see all these beautiful things. Here's an augmented triad, A flat, C, E. 2 major thirds in a row. Here's a diminished, A, C, E flat. Any 2 on a diagonal is going to be diminished, right? And so there you have it. Okay. Any questions as we wrap up here, ladies and gentlemen? That is some complicated stuff when you first look at it. Now, there is a note lattice. Now, Aladdin didn't develop this, hi Prella, did not develop this, this lattice, but what he brought to it is the way that is notated on Montoya's Great Listening. If you go look at it now, and here's one for you, and here's one for you. You can print this out as many times as you want. I actually went in my computer and made a new copy of this so that I could just print it out whenever I wanted it. But there's an extended lattice. You'll notice key of C is in the middle. And depending on where you see the clefs, watch carefully for the clefs. You will see how the notes all align. Mine is perfectly up and down and side to side, but this one is skewed on an angle. And so this staff orientation is kind of a thing that is new in harmonic experience in the book, which is beautifully organized.
It's not in the book.
It is in the book.
The lattice.
Yeah, the lattice is all over the book. Yeah. And going up fifths and down fifths and up thirds and down thirds. This is what finding these ratios and what finding these harmonies and what they sound like is all about. All right, we're going to stop there, ladies and gentlemen. Enjoy it. I would go and try and write out some a lattice, start to try and visualize it and internalize it, and try writing out those ratios and come back asking questions. I know that that was a whole bunch. So we'll see you next week. Next week, July 7th, because it's a holiday on Monday. Okay, thanks.